Hi students, you're watching iTTV. Thank you for watching iTTV. Do you still remember what we learned in our previous lesson? It was all about concept of mass, weight and the measuring tools. So today's lesson, as I promised you in the previous one, would be a continuation of the previous lesson. Let's start today's lesson, the measuring tools. So in the previous lesson, what did we learn, students? We learned all about length and how do we actually measure length by using meter ruler, measuring tape and so on. So today's lesson would actually begin with things about the area. So what is area actually? It's the surface covered by an object. That is actually area. Let's see further of how do we actually measure an area. Measuring area. The SI unit for area is square meter. So you can see the unit actually used is square meter. To measure smaller areas, we can use square centimeter and square millimeter. In the previous lesson, I've told you that to measure the length of a short straight line, we can use centimeter and millimeter. So obviously, to measure a smaller area, you can use square centimeter and square millimeter. Square kilometer is used to measure larger area. So you can use three different types of units to measure area: square millimeter, square centimeter and square kilometer. The main SI unit for measuring area is square meter. The relationship between the units of the area are 1 square centimeter is equivalent to 100 square millimeter. 1 square meter is equivalent to 10,000 square centimeter. 1 square kilometer is equivalent to 1 million square meter. So this is how you actually convert the units, which is square centimeter, square meter, square kilometer and square millimeter. Remember the conversions as you would be using them further in the lesson. Area of regular shape. The area of a regular shape can be measured by using mathematical formula. So here we would actually learn how to measure regular shape and irregular shape. Firstly, we start off with regular shape. Now, what kind of regular shapes do you actually know? As you can see in the picture or in the graphic, there are a few different types of regular shape. We also can measure cuboid and cube, which is a regular shape using mathematical formula. Let's have a look at the formula. Area of a regular shape. For example, the area of a square is length times by width, or length multiplied by width. In this picture here, you can see a square. So both the sides of the square would obviously be the same centimeter, 4 centimeter by 4 centimeter. So to actually get the area of a square or a cube is to times it by 4 times 4, it gives you 16 square centimeter. This is how you actually get the surface area of a square. Let's see further. The area of rectangle is length multiplied by width. This is the exact formula that we used for square. You don't have to wonder why, but both the formulas are the same for square and rectangle. In this picture, have a look at the picture. We have got two sides, which one is 5 centimeter and another one is 6 centimeter. According to the formula, to find the surface area, you have to multiply length with width. So 5 multiplied by 6 gives you 30 square centimeter. This is how you find the surface area for square and rectangle. Just remember the formula, length multiplied by width. This was all about the regular shapes. What about irregular shape like leaves or so on? How do you actually get their surface area? The area of an irregular shape can be estimated using graph paper. Trace the shape of the irregular shape on the graph paper. Every square that is fully covered, half covered or more than half covered is ticked. Count the total amount of ticks counted and it gives you the estimated area in square centimeter. Let's have a look at what do you actually get if you use the leaf, the graph paper, to actually measure an irregular shape. This is the result of the traced leaf earlier. So have a look. I have ticked the amount of boxes which are fully covered by the leaf. So the tick here gives you 72 square centimeter. Now remember that a small box in the graph paper is actually 1 square centimeter. So if I tick 72, then I have 72 square centimeter. The X here I have used to resemble more than half square or nearly full square. The amount of cross that is present here is actually covering 22 square centimeter. So how do you actually find the surface area of the leaf? Simple, just add the amount of ticks and the amount of cross in this picture. It gives you 94 square centimeter. Now is it only the leaf that you can use? I have used another type of leaf right here, and this is the results which I got after using the graph paper to count the surface area. The amount of ticks were 18 square centimeter. And the amount of cross, which covers the more than half covered square, is 25 square centimeter. When I total them up, I get 43 square centimeter. 43 square centimeter is actually the surface area covered by this weird shaped leaf. So let's move over to the last object which I used earlier to know the surface area of this irregular shape. The amount of ticks were 20 square centimeter and the amount of cross were actually 13 square centimeter, and I get a total of 33 square centimeter surface area. So I really hope students that you have an idea of how to use the graph paper and any irregular shape which you can trace on to find the surface area of a given irregular shape. Now, how accurate is this measurement? Can the measurements taken like this taken for accuracy? It is important that when a scientist takes a measurement that it is accurate. We can't find 100% accuracy, so if you can't get 100% accuracy, then an experiment carried out would not be correct. So obviously, in measurement, accuracy is the most important thing. So how do you actually increase the accuracy of certain experiment or measurement? Let's have a look. Firstly, you use suitable tools. Now to measure length, we use meter ruler. To actually get surface area, we use graph paper. So this is why you should actually use correct tools to measure certain area or the distance between 2 points, which is the length. If you mix up the tools, then you would not get an accurate number. Next, we use right technique. You remember, or do you not, regarding the parallax error? It is the error while measuring the length of an object using a ruler. Make sure to see right above while taking the reading. Do not see from the side or from the other side, as this will give you a wrong reading. This is how you make sure you have the correct reading by using the correct technique. Let's have a look at the last way to increase the accuracy of certain measurement. Taking several readings. Now mostly we would take 3 readings. Let's say we take the length of a pencil or a magic pen using ruler. We would take the length of the pencil or the magic pen at least 3 readings. Then when you get the 3 readings, let's say 5 centimeter, 5.5 centimeter and another 5 centimeters for the length of the pencil or the magic pen, all you have to do is add 5 plus with 5.5 plus 5, then divide them by 3. The value that you get would actually be the value of the magic pen or the pencil. This is how you get a few readings regarding certain length or certain surface area of the ones that you want. So this is how you actually increase the accuracy of a reading. So I do hope that you can remember how do you actually measure area and what is surface area and how do you actually increase the accuracy in this segment. Let's move over to the Do You Know segment to learn something about this special person. was Archimedes? The person who solved the dilemma of finding the volume of an irregular shaped object was Archimedes, 287 BC to 212 BC. This was how long he stayed alive. Thanks to Archimedes, we now know what is volume and so on. So now you have an idea of what is our next segment all about. We are going to learn all about volume. Let's go, students. The SI unit for measuring volume is the cubic meter. So surface area was all about square meter, square kilometer, square centimeter and square millimeter. Now we have a new term which is cubic. So remember, the SI unit for volume is cubic meter. We can also use cubic centimeter and cubic millimeter, just like surface area, square centimeter, square millimeter. Here we use cubic centimeter and cubic millimeter. The volume of liquids. The volume of liquids are measured by milliliter and liter. So this is how you actually measure the volume of liquids, by using milliliter and liter. What about volume of solids? The volume of solids are measured by cubic centimeter and cubic millimeter. So, to measure the volume of solids and to measure the volume of liquid, they actually differ. Liquid we use millimeter and liter, but solid we use cubic millimeter and cubic centimeter. Let's see further. The relationship between the units of volume are 1 cubic centimeter is equivalent to 1 milliliter. 1 liter is equivalent to 1000 milliliter, which is equivalent to 1000 cubic centimeter. 1 cubic meter is equivalent to 1 million milliliter, which is further equivalent to 1 million cubic centimeter. So this is actually the unit of conversion. The important thing you have to remember here is 1 cubic centimeter is equivalent to 1 milliliter. The rest you can figure them out. Measuring volume of liquids. Use a measuring cylinder. So when you think about measuring volume of liquid, we always use the measuring cylinder. Let's see further of what other tools can be used to measure the volume of liquid. More accurately, we can use pipette or a burette. So have you seen a pipette or burette in the school before? Later in the lesson, you would see them further in detail and how to actually use a pipette and a burette. The level of liquid is curved and this is known as meniscus. So do you have an idea of what meniscus actually is? Now how do the meniscus actually differ? The meniscus is actually the level of the fluid which you have to see correctly to know the correct reading in the measuring cylinder. Now have a look at the diagram here, which shows you water and mercury. Now why have I actually drawn water and mercury? Water and other liquids actually differ from mercury. Why is that so? It has all to do with the meniscus level. In water, the meniscus level is actually concave meniscus. What do I mean here? See, this is concave meniscus, but mercury has got convex meniscus. See how it differs? This goes down and this goes up. This is concave and this is convex. So this is the special thing about mercury. Mercury's meniscus differs from the meniscus of water and other liquids. How to use pipette? Make sure to place the measuring cylinder on a flat surface. Now why is that so? This would actually affect the reading of the measuring cylinder. When using a pipette, the liquid is sucked into the pipette until the bottom of the meniscus reaches the mark on the pipette. Use a pipette pump. Now, I would show you further of what a pipette pump actually is and how a pipette, which is a simple one, actually looks like. Then the accurately measured liquid is released into an empty container. So this is how you actually measure accurately the amount of liquid needed for certain experiment by using pipette. What about burette? How does it differ from pipette? When using a burette, clamp it vertically on the retort stand and pour the liquid into it with a filter funnel. So when using a burette, what do you need? You need a filter funnel and you need a retort stand other than the burette. Well, you also need a beaker or a conical flask to put it below the burette to actually collect the fluid which is flowing from the burette. Then the clip is turned slowly to release the liquid into an empty container until the level reaches 0 in the burette. Now this is how you actually use the burette. It's quite simple. Let's have a look at the way you actually use the burette. Now how do you measure the volume of solids? Earlier we have learned about measuring the volume of liquids. Let's see what is so great about the solids and the way of measuring the volume of solid. Use water displacement method to measure volume of regular and irregular solid. So what is actually regular and irregular solid? It's just the shape of it, a cube and a cuboid, which, for example, a sugar cube or a chocolate, for instance, is regular. Something irregular is actually something like an irregular stone and so on. Let's see the way that we use to measure volume of solid by using water displacement method. Firstly, fill the measuring cylinder with water and record the initial volume, then slowly lower the solid object into the measuring cylinder and record the final volume. The difference between the readings is the volume of the solid. So what do you actually do? Slowly take the irregular shape or the irregular solid and put them in the measuring cylinder filled with water. Then take the difference between the first reading and the second reading. For solids less dense than water, a weight is tied to it before immersing it into the water. Now can you name me a type of solid which is less dense than water? Take a cork for an example. It is less dense than water. This is how you actually measure the volume of a cork. We can also use an eureka tin to measure the volume of regular and irregular shaped solids. So remember, all we need to measure the volume of solid is the measuring cylinder, a string to tie the regular shaped object, either a rock or an eraser or a cork or so on. Then lastly, we learned about the eureka tin. The amount of volume in the eureka tin is actually equivalent to the volume of the solid. So this is all about volume. We have learned the measuring cylinder, we have learned about the pipette, the burette, and the correct way to see the meniscus and to read the volume of a liquid. So let's go further into the exam lab and see how much of today's lesson did you understand. Question 1. Which of the following is not true about measuring an area? A. The SI unit for area is square meter. B. To measure smaller areas, we can use square centimeter and square millimeter. C. Square kilometer is used to measure larger area. And lastly, D. 1 square centimeter is equivalent to 10 square millimeter. So, which is not true about the measuring tools of an area in this question? The SI unit for area is square meter. Now that is true. What about B, C and D? Let's see the correct answer. The correct answer is D. 1 square centimeter is equivalent to how many square millimeter? It is 100 square millimeter. This is the correct answer. So D is not true regarding measuring tools of an area. Let's go further to question 2. The volume of liquid are measured by using A. Milliliter and liter, B. Square centimeter, C. Cubic millimeter and D. Square meter. Now let's remember, to measure the volume of liquid, what do we actually use? The word square here actually refers to area. So the answer option B and D is obviously not correct. Is it A or C? The correct answer is A, milliliter and liter. This is how we actually measure the volume of liquid. Do you still remember the equivalence or the conversion of unit? 1 cubic centimeter is equivalent to 1 milliliter. Liter is something that we use to measure large amount of volume of liquid. Let's move over to question 3. What is the method used to measure volume of solid? What do you think? What is the correct method used to measure volume of solid? Do you still remember the eureka tin? Do you still remember the method which I taught you earlier? Let's see the correct answer. The correct answer is water displacement method. So what do you actually use? We need a solid obviously, and we need water and measuring cylinder. By using all this and thread, we can actually know the volume of a regular solid and an irregular solid. I'm sure you answered all the questions correctly. It was not so difficult, wasn't it? So let's move over to the summary of the day and see what have we learned so far in today's lesson of measuring tools. The SI unit for area is square meter. To measure smaller areas, we can use square centimeter and square millimeter. Square kilometer is used to measure large or larger area. So remember that the SI unit for an area is square meter. Area of regular shape. The area of regular shape can be measured using mathematical formula. What is the formula? Length multiplied by width. The area of an irregular shape can be estimated using graph paper. The SI unit for measuring volume is the cubic meter. We can also use cubic centimeter and cubic millimeter. The volume of solids are measured by using cubic centimeter and cubic meter units. The volume of liquids are measured by milliliter and liter. So now you have an idea of what today's lesson was all about. I am sure you can remember all the conversions, all the formulas and all the units correctly. We have reached the end of the lesson, students. So this was all about measuring tools. I will catch you soon in our next lesson regarding a new chapter. Till then, thank you for watching iTTV. Take care and bye-bye.